gravitational acceleration. By now, every one of you should have a good idea about gravitational acceleration, which is negative direction, 9.81 always. So our plan is actually to calculate that by measuring the displacement and the time of a free falling. Free falling object means we're going to let the object fall down because gravity is dragging it downward direction. Then we can measure displacement as a function of time. That's what we're going to do if this is an in-class experiment. However, since we don't have that in-class experiment facility now, what we're going to do, we're going to drop the object and make a video. So those are the videos which I mentioned earlier. If you go into this tracker, that folder, there's 3 different videos. Okay, one says the golf ball, other says the tennis ball, other says the coffee filter. So technically, we're going to analyze the golf ball first, and then the tennis ball is repetitive measurement of the same thing. And the coffee filter will show you a completely different scenario. Okay. So what we're going to do, we're going to use that video to extract the data. So what the data we're extracting is actually displacement and the time. That's all. It's very simple. So that extraction of data going to be done by using this software. That's why you need that. Okay. Let's take a look at a couple of other things. By now, you know all the information. This equation number 4, you are now very much familiar. When object moving on y direction, if I put the y0 into 0, initially starting point, v0 times t is equal half gt squared. If v0 initial velocity is 0, which means if I drop the object, then that formula going to be reduced into y equal half gt square. Very simple, right? So that's what our plan really. So that formula we can use to analyze and then calculate g by measuring the displacement versus time. So that's all. If I measure y versus time in a falling object, then we can make a graph. By using graph, I can extract this parameter in front of the t-score. By knowing that, I can calculate the g. So, and on the other hand, if I know the displacement and the time, by using those information, I can calculate another parameter, velocity, because velocity is rate of change of displacement. If I calculate velocity, then I can use equation 6 also to do the same analysis. Now, equation number 5, you can see look like a parabolic because it e to the power 2. However, because you know we talk about that many times in the class, displacement is behave as a parabolic shape with respect to time, but the velocity should be behave as a linear because rate of change of velocity is acceleration. Acceleration g must be constant. So this is going to behave like a linear shape. So I can make another graph, velocity versus time, and then by using that graph, I can calculate gravitational acceleration again. That's actually the plan. So to do that, I need an object. I need to have a video record that object. So these 3 videos, please download them, are recorded in a slow-mo mode. Because of that, time must be corrected. Immediately when we put the videos, so add the videos into the tracker software, there's a way to do the time correction. Please follow that steps very carefully as I explain. If you do any mistakes there, then the final data we extracting will not be accurate, okay? And to get the displacement, I have to give the initial height where the object is dropped. That's the only information tracker needed. That actual information given here, that's 6 feet above the ground, okay? It's roughly, we're going to see a little bit of error, that's okay. 6 feet in meters, about 1.828, okay? All right, any questions so far? Okay, then let's start. Let's take a look how to, everybody, I think, have the tracker software installed now. If not, just do it right now. It's going to take like 1 or 2 minutes to complete the process. When it is installing, it might ask you to download the videos. They have a video library, but do not download any of their videos. because we're going to use our own videos to do the analysis. Okay. And this should be working fine both OS, both operating system, Windows and the Mac. Okay, anybody have any question?
When I put a video into the tracker, it tells me there's like a discrepancy with like the frames. Is that fine?
I will show you in a bit that. Any other question? Okay, now if you have the tracker on, then let's import the video. So go into video on the very top, then do import. And then first object, we're going to analyze the golf ball, double click, it will load it. It's going to take like few seconds. It has like many number of frames because it's done in slow-mo mode, right? Okay, so after it load, you will see this error message. Just click OK. And then you can see video is on horizontal direction, which is not good. Right click and then click on filters, new, rotate, and then click negative 90 degree and then click OK. Then the video automatically change its position into vertical. Okay, this is a vertically drop object. Because of that, we need to see it vertically. Okay, now you can see the golf ball here. We're going to drop that. And this step number one, most important step here is that you have to change the frame rate because it's done in slow-mo mode. Otherwise, the timer given automatically from the tracker will be inaccurate. So to make that correct, right click on the video. Then you will see clip settings. Then go there and then you will see the frame rate. Then change that into 240. 240 and then click OK. And then click OK again. All right, any question? Everybody have the video uploaded? Video imported into the tracker and then everybody on the video and rotate it and then make the frame rate corrected. Everybody done all of those. Anybody have any question with any of those? If those are incorrect, then you will see a huge problem, okay? Because the timer will not be accurate. If timer is not accurate, everything later, the information we extracting will not be accurate, okay? Right click, filters, new, and then click on rotate. Okay, good. And most important thing is the frame rate that must be corrected. That is extremely important because otherwise you will not get the right time. So the frame rate should be 240 per second, okay? Okay, now just we need to let the object fall and then collect the data, right? Now to do that, you have to tell the software how high you actually fall it down because software has to know some information, right? Otherwise it can't give the right height, right? Displacement versus time. Now to do that, what you have to do first, I need to get the XY coordinate system first. To do that, on this very top menu bar, you can see an icon just above this hand, just like a two lines. Okay, just bring the cursor on top of that, then it will show you that is the coordinate axis. Click on that, then you will see this vertical and horizontal line. So that's our XY coordinate axis. Now object moving downward direction, because of that I would like to have my 0, 0 on the object starting point, right? Now that's the starting point. However, if you go into this bottom panel right here, very bottom of the video, you will see a couple of icons. One is green color arrow. So that's the play button, right? So let it play. And then you will see ball is not dropping for a while actually, okay? Because this is done in slow-mo mode. So to find where the ball is dropped, you can stop and then click and drag the slider. You can see a slider on the play, just after the play, right? So just slide it, click and drag to figure out where the ball is dropped, because there are a lot of frames before the ball drop. Those frames technically we don't need, right? Let's figure out that's the position where the ball is dropped, but I need to go as close as possible to the ball dropping point, right? To do that, you can see your right hand side where bottom after the slider, there's a two arrows, blue, up and down, and also the number here you can change the how many number of frame you want to change each time you click these arrows. I'm going to leave it one, that's okay, and then go backward little bit to bring the ball back just after it dropped from the fingers. It should not be on the finger, but it should not be further away from the finger either. Okay. If you try to do exact pinpoint, try to pinpoint exact location just after it leaving the fingers, it's very difficult to find. Okay, bring it as close as possible. That's good enough. So which means technically that V0 location, y-axis V0 location, when it drop exactly, pinpointing that point is very difficult. That one error adding into this measurement, what we're going to do now. Okay, we assume that is my 0 point. However, ball already have a little bit of velocity there, because I can't pinpoint when the ball leave from the hand. That almost impossible to do. But that's okay, as close as possible. Should not be on the fingers, but should not be further away from the fingers either. Okay. After you get there, then usually I should place the y-axis here. But if I do that, when ball goes downward direction, ball gonna be hiding with that pink line. Y-axis, because of that, I'm gonna leave it y-axis a little bit further away. And I'm gonna put x-axis exactly at the middle of the ball. Technically, what we're doing, we're tracking the center of mass of the ball. Ball is little bit larger, but we're tracking center of mass point. Okay. Question. All right, so now as I put the axis system there, now I can actually tell the program how high this axis is, how high this 0 from the ground, right? To do that, you have to go to the other icon just left from the axis icon. Axis icon is coordinate icon right here on the top menu. Just left to that, you see another icon shows show hide create calibration tool. Just click on that, then you will see new, and then click on calibration stick. And I need to have the calibration stick, so I have a calibration stick now. If you click on the shift icon, shift button, then you will see the mouse icon changes into like a box shape like this. You see that? Mouse icon is arrow now. Whenever you click the shift, now mouse icon changes. Okay. Click the shift icon, shift button, then bring the mouse top of the 0 point, that is the crossing point of the two axes, and then click there. Then you will see it as a blue line. Blue color. Then go all the way to the bottom here, ground point, and then click the shift button again, and then click as close as to the ground level. Okay, that's close as to the ground level. So that highlighted blue line is the meter stick. You have to do twice shift and click. Okay, shift click on the 0 point, then shift click again, shift and the click together again right here in the very bottom. Then you will see this small box highlighted here that tell you a number that is not the right number. You have to change it. So number we needed 1.828. Let me check that number again. Feet to meters. I have about 6 feet, about 1.829. So that's better. I think I can go 3 sig figs up to 3 sig fig 1.829. Question. Now, if you've done all of this correctly, you should have this blue line, this number, this box. You can click there on the box and then change. So you have to change it to 1.829 meters. Okay. And the ball should be on x-axis. Y-axis, I bring it a little bit to the left because when the ball goes down, I need to observe the ball clearly. It should not be hiding under these two lines. Okay, that's why I keep it Y here. Question. Okay, now let's take the measurements. That's all really. Everything is ready. Now all we have to do, let the ball goes and then collect the data. Now to do that, you have to tell the program what we're tracking, right? So to do that, you have to create right here. You see right from the coordinate icon right here on the top menu. Right to the coordinate icon, there's a create icon. Just click on that. Then you will see a couple of options. Out of that, create the point mass. So what we're tracking is the point mass. Okay. So we're going to track center of mass of the ball. As soon as you click that, you will see a small graph show up to your right hand side. That small graph, you have the axis there, time x-axis is fine, that's what we need. But the y-axis, we're not interested x at all. Ball is moving on y. Click on there, one click, then you can see many different options. Change that into y position, y component. Y position, Y component. That what we interested. Then as the ball goes down, this will show you the behavior of the change, displacement versus time. Technically, this software can do all the analysis, what we're doing with the Excel, but we're not going to do with this software itself because we would like to do all the analysis with the Excel as we're doing so far in all the other labs. Okay. Software we're going to be using only to extract the data, y versus t. That's all really. As soon as we get that data, then we don't need anything from this one. The rest of the calculation and analysis we can do ourselves. Now, as soon as you do, then you will see this the slider on the bottom change back into 0. You see that? So I have to bring it back again to the ball exactly dropping point because there's a lot of frames actually before the ball dropped. So I don't need to just click forward button that many frames. It's about, you can see 355 or 35 frames. I can actually find out where the exact point ball is dropped. Maybe that point, yeah. So that's going to be a little bit relative to person, okay? But you have to pinpoint as close as possible. Question. Anybody have any problems so far? No problems? Then let's continue. Okay, seems to be no problem, so we can continue then. Okay, now to continue, now that is my initial point, right? So you can see that is frame number 357. I can actually set that is my starting point right here. Or we can actually correct the timer later. So there's two ways we can go. I can correct the timer here, set time to 0, then it will start collecting with 0, or I can correct it later. We can correct that later, nothing to worry. Just leave it like that. We're starting at 357 frame, that is our 0 point. Okay. If you bring the cursor everywhere here, now you can see this yellow place show you coordinates, right? You can see y coordinate should be always a negative number because I'm on negative direction of y. Okay. Now all we need to do is the collect data, right? To collect the data, what we have to do, shift again. You can see mouse icon changes into like box shape. Then bring the mouse exactly top of the ball and then click there. So we collecting the ball as we go on. As soon as you click on top of the ball, red color box should appear. As soon as the red color box appear, there's a dot should appear on your graph page. That is our first data point. So now this is collected, y coordinate and the time. Now you can see the time it collected is not right. It's not 0. That's okay. Don't worry about it. It says that is 1 second dot 492. That's we can correct it after we get the information from this. Okay. Now the x component we don't care at all because we're interested in what's happening in the y direction. However, y you can see very small positive number. It's e to the negative 17. I need to make it 0, right? So that also we can correct after we get the data into our Excel, or we can correct it here too. If you want to correct it here, you go back, bring the mouse again to the red box, click it once. Then just top of the video, you can see a couple of new boxes appear. In there, you can see the y coordinate inside the white box. Just click on there and then enter 0. Type 0 and then enter. That should correct. Let me see why it is not allowed. Okay, so we can do another way. Just click on this this red box and then you can use the arrows, up and down arrows, to actually change the position until it reach to as close as possible to 0. Okay, if it is impossible to get it into the 0, nothing to worry. That also we can correct it after we get the data. Okay, I was wonder why it is not. That's okay. Let's correct it after we get the data. It's not a big deal. So all of these data actually can be corrected here too. That's okay. So everybody have any question at this point? Now technically what our assumption is that when the ball drop, that is our initial point. That should be t0, y0, right? Instead of that, now y is very small number. You can see negative 0.002876 and the time is positive 1.492. Both of them we have to correct after we get this information to the Excel. Okay, that's important. Question. All right, keep that in mind. Okay, if we don't do that correction in the Excel analysis, we're going to see huge difference and then huge error. Okay, that's step number 1 when we do the analysis on Excel. All right, now let's collect the data. So to collect the data, what you have to do, you have to let the ball goes downward direction. And then after ball moves little bit, then we're going to click again, collect the data. And then let the ball goes little bit, click again, collect the data. Now to do that, don't click the play button, then the ball goes downward direction rapidly. Instead, use this forward arrow just on the very bottom, forward arrow towards your right. If you click like maybe 1, 2, 3, 4, 5 or 6 clicks, then you can see ball is now a little bit off from the previous point. Click the shift button again, bring the mouse very top of the ball. It should be because you tracking the center of mass. Remember, center of mass is exactly at the center of the ball. You have to click as close as possible to that. Okay, that pointer right here you see the mouse becomes look like a pointer now, the cross sign, and then that middle point should be at the middle of the ball. Okay, if not, we adding an error. So there are going to be error anyway in this experiment. Okay, that's a good thing. Click once, then you can see the next data point appear, and then couple of click on the forward button, shift, next data point, couple of clicks, maybe 5 clicks on the forward button, maybe like 5-6 clicks, shift, and click on the ball, and another 5-6 clicks, shift, and click on the ball, and then you continue like that. Don't let the ball go more further away from the previous click, then we have a huge difference between two data points. That's not good. Okay, we need like maybe 15 to 20 data points. If you collect the data closer, that's better. Okay, but you don't need really 50 data points either. So if we have 15 or so data point, that's good enough. Okay, click maybe like 3-4, then you can see ball is like about little bit off from the previous location. You can visually see that. Then collect the data. Couple of clicks and then collect the data. Maybe as the ball goes down, you should not click more because the speed becomes more and more faster. Each click, ball goes fairly large distance. Okay, maybe 2-3 clicks enough now. Don't click more than like maybe 3 or 4 clicks. Okay, maybe 2 or 3 clicks, I think good enough now. And you continue like that. If this error message appears, just click that away. 3 clicks, click on the ball, another 3-4 clicks, click on the ball, another 3-4 clicks, and then so on. You continue this all the way downward direction. And if everything goes fine, if our motion is actually parabolic, by now you should see this nice parabolic behavior. You see that? So that's our data. So we could analyze everything here, but instead we're going to bring the data into Excel, do the analysis there. Okay. Couple of click, forward button, then collect the data. Couple of clicks. Now actually maybe 2 click is good enough. You can see it moving much faster. If you click 2, it going much further than the previous stop. 2 click is good enough. Okay, and let's collect few more data points. And do not go all the way until it hits the ground either. So you should stop collecting the data just before it hit the ground. Okay, so do not collect any data point after it hit the ground. That's going to be huge error adding into your data. So you should stop just before it hit the ground. Maybe by now we have enough data, actually more than 20 data points. That's good enough. We can stop there. Correction. So that's my data collection. And then if you right click on this graph area, a new window appear. If you click on analyze, then you will see that graph very nicely. You can see, and also you can see the data we just collected. Okay, because we're not interested X line right here. That's why I open this new window, and then I'm going to collect this data, these two columns, T and Y. So that's our data. Question. Rest of the analysis we're going to do with the Excel. We can even do with the here the analysis. If you right click, we can fit all the data. If you go into analysis, curve fitting, you can see I can select the parabolic fitting here. To get some practice, you can do that. Parabolic fitting, you can see very nice fit, and it will give you all the information. The number in front of the 0, E1, and then all the other information. By knowing this is the number we actually expecting. Number in front of x to the power 2, that is easy. This is 0, sorry. The number in front of x to the power 2 is actually this number right here. Negative 4.984 E0 means 10 to the power 0, that is 1, okay? Which means if you multiply this number by 2, I'm getting very close to 9.81. So this data is very perfect. So we could do that analysis here very extremely easy, but that we don't like to do actually. Okay, so let's copy instead of data. Anybody have any questions so far? To copy the data, click on the first cell, click and drag, and whole thing. Then you can right click and then copy, select all, copy, or you can just copy by using your mouse, by using your keypad, okay? Either works. Now you bring that data into your Excel sheet. This is the Excel sheet, okay? Now this is the column which I like to insert that data. However, data should be corrected before I insert here, right? Because of that, I would suggest open another sheet on your Excel and then put the data here first. That's my data directly coming from the video analyzer, okay? Tracker. But that data has to be corrected because that time and that y both are not correct because these 2 points should be corrected into 0. Let's correct that first, then copy back into here corrected data. Okay, that's our plan. Question.
If I manage to start at y equals 0, I don't need to change my y value, right?
Yeah. If you see this y equals 0 there, that's fine. Then you don't need to correct that. And also we could actually correct both of them there, right? We could correct even time there. If you have it, then nothing to worry. Just you can copy this data directly into the right table. Let's correct this data. Then I need to get rid of this number from here, from everywhere, right?
Can you show how you copied it from the program again?
How to do that? You go back to the program, this graph area, right click, analyze, then this new window open up. Then on your right, you will see the data column. Just click and drag to select all. I think even the right click work, right and do select all, it will select all automatically. Then right click again, copy content. Then you bring it to Excel and then paste it. Okay, question. All right, now let's correct this data. Okay, we could do it there. If you do it, then nothing to worry. But if not, make sure you correct it. Now I'm going to correct the time again. T corrected value, which means equal sign. Before equal sign, copy this whole number. Number there, 1.49, whatever the number is, copy that. Okay, then come here, equal sign. This cell is A3 minus copied value. Just paste that whole decimal places. You can see we can observe only few decimal places, but inside the cell there's many decimal places. Okay, hit enter. Now that becomes 0, which means I have to subtract this number from every single cell. To do that, you go back to the same cell, C number 3, right hand side very bottom, solid green dot, click and drag. Now that's the corrected data. Okay. I need to recheck whether I corrected the time, yeah, right? Frame rate, because if that's not correct, then everything is incorrect later. Okay, make sure this number right here, 1.829 meters, and then right click, clip setting, frame rate should be 240. Okay, that's extremely important. If those are not correct, then everything else we're going to do now going to be incorrect, which is very bad. Okay, everybody good? Correction? Okay, then let's correct the y. I need to get rid of this number again. Copy that whole number. Right click, copy, and then click again here on D number 3, equal sign. This number, now it is a negative number, right? Because of that, you have to add the other number, copied value, okay? Need to get rid of that negative sign in front, only the number. If you do that, now that y cell becomes 0, which means I have to add the same number from all the values of y to get rid of that number. So click on that cell, right hand side, solid green dot, click and drag. That will correct the y-axis too. It's a little bit of difference, not much actually. Even you leave it like that, I don't think it's gonna do a lot of error in our later calculation, but it's not looks nice because we know that should be our starting point. We assuming that is the right y0 and t0. So we have to have a data set look like this now, okay? Now you have corrected time and y. Now you can copy paste into the right table. You can highlight y, copy, go to the sheet 1, and then click here. When you pasting, you may need to do this way, right click, then you can see different option for the paste. I would think this last one is the only one works fine, okay? And also you may need to check, there may be not enough columns here, right? Not enough rows here, because I have how many data there, how many points? I have 28 minus 2, 26. But here I don't have that many. Starting 10, ending at 21, I have only like 11. So which means I need to add many rows here, right? To do that, you can click on this number anywhere, any of these numbers, and then add little bit of rows there. Click on this number, left hand side, very corner, any number doesn't matter, just after this, okay? Any number, even inside here, doesn't matter actually. Just click there, then insert. Then you can do that few more times until we get the enough rows, okay? Because I collected more than the data I would anticipate it. I would be thinking maybe 10, 15 data points, but seems to be I collected maybe 20. And also we don't need all 20. Technically, we can maybe bring half of that, or maybe 3/4 of that, or maybe 2/3 of that. That also fine. The last few data point you can skip if you don't want to add more rows here, okay? But I will add little bit of more rows. This is starting at 10, now it is 29. So it has 19. Let's add more. 10, and then now it has actually 20. That's maybe good enough. Let's go back there. 28 to 26 data points. We can get rid of last 6. 1, 2, 3, and then another 3 here. Let's copy this area. That's good enough. So I'm getting rid of last 6 data points, okay? But if you want, you can add more rows and then bring all the data. That also fine. Click here, right click, and then maybe you have to click this last one. Otherwise, you can see it not giving you the right number. Maybe 1, 2, 3 also seems to be giving you the right number. Yeah, paste values will give you the right number. None of the other ones won't give you the right answer, okay? Make sure you do correctly, copy and paste. Have 1 row more, that's okay. Nothing to worry. Now that's my Y data points. Question. You have to do it correctly, okay? The data table which I gave it to you doesn't have enough rows here on the table 1. So I add little bit of rows. because I have here about like 26 data points. Even adding that, I did not add all 26. What I did, I add data until I get maybe like 20 data points from here. 20 is good enough from starting side, okay? 0 points should be there.
Sorry,
Question.
Professor, one more time. Could you show how you calculated the new t and y values? I'm not getting the right answers here.
You have to first click on the cell number A, number 3, and then copy this whole number. Highlight everything, right click, copy. Then click on the cell number C3, equal sign, A3 minus, then paste that whole number you copied earlier. Then hit enter. Then you should see 0 here. If not, you are not doing correctly still, okay? Check that.
Now it's working. Thank you.
Okay, and then you have to do the same for the y also. When you copy in the y this number, copy that without negative sign. Without negative sign, copy. Then D number 3, and then equal sign B3 plus previous copied number. Okay, because now this number is negative, then I have to add that. Okay, if you do that, you will get 0. Then click and drag, then you will get the corrected y. Then let's copy corrected t also. We're copying only 20 data points. Okay, so we're gonna get rid of last 6 data points. If we have like anything more than 10 data points, that would be enough for this study. Okay, we even don't need 20, but more the data, that actually better, because this is a parabolic shape, right? So it's unlike the linear line analysis. If you have a parabolic, more data you have, then your fitting is better, then your answer is better. Let's copy that, right click, and same I have to do values. Okay, all right. So I have 20 data points. Make sure you check this should be match, okay? Last data point and the first data point should be match each other. All right, question. Everybody okay up to that point? Okay, then let's continue. Now all the rest is actually calculation. So I'm gonna calculate velocity, we're gonna calculate gravitational acceleration. We're expecting 9.81. We're gonna compare that with the expected value negative 9.81. So to calculate velocity, if I assume initial velocity is 0, then I can use the idea of the average velocity, right? You know, average velocity is, write it down that somewhere here. You know, the average velocity is V average VAVG, which is V final plus V initial divided by 2, right? Which is also equal delta Y over delta T. So if I assume initial velocity 0 right here, right? See, if that is 0, then I can say V final velocity, that is this VI right here, represent ith number. Okay, let me change that into, otherwise you will confuse that with the initial. Let's say that is Vn, nth velocity. Okay, Vn, which is equal 2 times y of n divided by t of n. Okay, this n is subscript. Okay, so which means that is a subscript. Okay, which means nth velocity, that is the final velocity. Okay, V final, which is equal 2 times delta y over delta t. Usually when you starting y is 0, that's why it's written this way, 2 times y of n divided by t of n. N is actually the number of point. Okay, starting point is 1. This is n equal 1, this is n equal 2, n equal 3, n equal 4, 5, and then so on. Okay, that n represent which point we actually talking about. Question. Everyone okay with that? Good. So I'm going to erase this. Okay, we don't need that. And also, let's erase that one. So that's why this velocity right here, you can see this velocity right here written that way, okay? 2yn over tn. Make sure these are actually subscript, okay? Change that little bit smaller. Yeah, good. Okay, correction. Then let's do that calculation. So how to do the calculation then? Then initially I don't have y, that's going to be 0 anyway. I can do the calculation from here, right? Very easily. Equal sign 2 times y displacement divide by the time. Okay, and then if you do once, then you can click and drag downward direction, then we can easily do the rest. But there's an error here, right? Because you know initial velocity, what we expecting or what we thinking. This is the initial velocity 0. That is our thinking. But we know that is not correct, right? Because we know we can't really pinpoint that dropping point, right? From a ball goes away from the hand, it's extremely difficult to pinpoint. Because of that, there are going to be a little bit of error adding here. That's okay. That's nothing much to worry. Now let's calculate gravitational acceleration. So the gravity is the acceleration. So you can calculate acceleration, which is rate of change of velocity. So which means I can say velocity final minus velocity initial divided by the time. Now to do that, what we're going to do, we're going to do it for each two selected velocities. Okay, we're going to select each two at a time, velocity and the time here, then we're going to do the calculation. Let's do that calculation here first. Everybody okay with the velocity, this column? Everybody okay with the velocity column?
I'm
Let
sorry,
me
could you
copy
repeat that
paste
again?
that function. Yeah, go ahead. What is your correction?
Oh, never mind. I'm good. Thank you.
Okay, let me copy paste that function here. You can refer that as needed. Let me see. It's visible. All right, so now you can visible that function. Okay, that is the function I use here. First line technically no meaning. Okay, that is our 0 point, what we thinking, but we know that is not the right v0 initial velocity 0 point. Okay, because of that we will get some error there. That's okay. Now let's do this calculation. Now what we're going to do, what x and y you asking? What x and y values you asking? There's no x values here at all. We have time and y values. What you asking? Russell?
Back when you were doing like B3 minus and then from the initial time that we had before. My computer froze. So,
This table or the sheet too? This
yeah,
one? This one?
yeah. So how did you get T again?
You have to copy this time right here, this whole cell,
Okay.
copy that whole thing, and then click on the C tree, and then subtract off that number. Equal A tree minus that copied number. Then click enter, then you should see 0 here. If you don't get 0 there, which means the calculation incorrect. We have to take a look again.
Oh, wait, so you did it for T of the A column, right?
Yeah.
3. Okay, that's where I messed up. Okay.
Yeah.
So repeat that again. Sorry.
Good.
Just do that one more time. I'm sorry.
The calculation you mean?
Yeah, for the T and the Y.
Yeah, so equal sign. First, you need to copy this whole thing. Okay, this click on A tree and then copy that whole number.
Okay.
Copy, then go to C tree, equal sign, A tree minus, paste that number you copied. Then you enter, then that should show you 0.
Okay.
Then you have to do the same thing for D3. Copy this number right here without negative sign. Okay, only the number. Copy. And then go to D3, equal sign, D3 plus the copied value. In this case, it should be plus because numbers right here negative. Okay. Then hit enter, then you should see 0.
You did plus. Okay. Thank you.
Okay, so now let's do gravity calculation. Gravity we're going to do by using this equation, right? Delta V over delta T. So which means you can pick nearby two numbers. That's why you can see these top two cells are actually colored. So the reason I can't do gravity or anything for those, okay? Because I have to use the two cells. And also I can't actually use this top cell either because we know initial velocity 0, which is actually incorrectly guessed because this is not real initial velocity 0 point. Because of that, that point for any later calculation we can't use. So let me highlight out that too. So those numbers we're not going to use. Because of that, we're going to start from here. Cell number E12 equal sign parentheses V final. I need to get rid of this first. Okay, this line is actually colliding with that. Okay, get rid of that. Equal sign parentheses D cell number 12 minus D cell number 11 close brackets divide by open brackets C cell number 12 minus C cell number 11 close brackets, hit enter. Then you can see we're getting a number which is not 9.81 but it close by. You can see as we go downward direction this number may change. Okay, number not going to be stay constant but we're calculating acceleration between nearby points. That's why I mentioned earlier, if these points are extremely close to each other you will get 9.81. But if these data points are further away each other, then you will not get that 9.81 because there's a lot of error in between happens. One error is initial velocity 0 is wrong. Because of that, they're adding a little bit of error there. So all the errors is adding up, and also when the time is when the 2 points actually we decide very further and further and further away, then we can't do this calculation right here, which we do. What we do in here is actually the average calculation. So that also will not be correct. Let me copy paste that function. This is the function we use to do this calculation. Let us copy paste to here without equal sign. Okay, otherwise you will see it as a number. Let us check. Okay, I think it's good. Check that again. Okay, so you can see that that is a function we're using. Okay, so that is a function I'm using to calculate the gravity. See, now you can see it clearly. Okay, question. And if you do it for one, this is starting from cell number E12. Okay, and then click on that cell, right hand side, very bottom, that green solid dot. Click and drag downward direction. Then you can see the rest of the stuff calculated automatically. You can see some numbers are very good, very close to 9.8. And some numbers are very off. I have even 13 here. I have 7. And then I have 8 different numbers. Maximum may be 13, minimum may be like 7. That's okay. That's part of the game. So it's not going to be constant. However, we can check the average. So let's check the average here. Equal sign, average. If you have many calculation, what you're supposed to do is actually doing the average, right? Highlight this whole range of data and then check the average. Average should be very close to 9.81. Now my average is 9.69. That's a very good number, within about like 2% or less than error. Question. Write it down. This is what we're doing here is the average of G, okay? Average of G equal this calculated cell right here. Okay, equation. No question? So that's the average value, okay? That's the function I use. Okay, now if you done up to that, let's do the percentage error analysis equal sign ABS parentheses expected value negative 9.81 minus calculated value right here on E cell number 12 close brackets divide by ABS parentheses minus 9.81 close brackets times 100. Now you can see that point has a large error, which is too much, but we can check as the different points are appearing, I should get a different numbers, right? You can see the error is changing and my average error is actually much better. So if I do the average, you can see error is less than 2%. That very, very decent, very good number. On the other hand, if you go different point, you will see large error. You can see this point is 32% error, extremely bad. And the following previous point, 14% error. And then I have even 40% error somewhere. That's okay. We are interested is actually the average, okay? As far as your average is good, nothing to worry. Question. Okay, now let's do graphical analysis, right? So I finished all the calculation, right? So now you can make two graphs if you go into the lab manual. And there are a couple of questions for each table. You can see right here, there's a couple of questions. It's asking you to do two different tables. One table is actually two different graphs. For the table number one graph is Y versus T, other graph is V versus T. Okay, you can see here. I need to do both graph. By using graph, I need to calculate gravitational constant again. So let's do that. To make the graph, it actually easy. Let me expand this one a little bit. Let's make the graph just nearby here. Insert, you know how to make the graph by now. So the insert, click anywhere other than the table elsewhere, okay? Insert, in the top menu bar, there's area called charts and then select the scatter plot. Scatter plot, then you will see an empty graph, okay? Then double click on the graph, then select data on your right hand side very top, click on that. Small window will appear, then click on add. Another window will appear where you can select the data. Now what we selecting the data is actually Y versus T in this graph, right? So the time should go into X. So which means what my time is column C, right? Let it start from 0 and then click and drag all the way to the last cell, C number 29. Then Y values right here should be my column B. Click on 0, drag all the way to the very end. That's the Y. Click OK, click OK again. Now, if all goes fine, I should see the same graph which I showed earlier, right? Remember when we do with the simulator, that shows you a nice graph. This is exactly the same shape. parabolic. Question.
Professor,
Yep.
for the percentage error, can you just show the function you plugged in again?
Oh, right. I will copy paste that function somewhere, maybe here. Let's copy paste into here. Okay, then let's expand this one. Then we should be able to see that. Good.
Yeah, thank you.
Okay, now since I have the graph, then let's do a little bit of work on there. These are the function which I use if you want. Okay, the velocity B11 over C11, the first number right here. Okay, you calculate that, then click and drag. Then the first number here for the G, first number for the percentage error. Okay. And since I have the graph, what I need is the graph axis chart and then those names. Double click on the graph sheet. Left hand side, very top, you will see chart elements. You need the axis title, both of them. And then you need the trend line right here. Left hand side, very top, chart element, trend line. Click more options. If more option is not show up, then you can leave it trend line linear. We can change that later. Okay, nothing to worry. Just click the linear. That's okay. Then bring the mouse cursor on top of that trend line. You can see. Then double click. Then you will see new window appear here. Very top, third icon. Very top, third icon. Then select the polynomial. If you select the linear, it should be look like that, but you know linear is not good fitting. But I have to change it to polynomial. This is second order polynomial function. Okay, y equal g by 2 times t to the power 2. Go all the way to the bottom of that menu and then click all these last 3 icons. Okay, question. Now you can see when I click this y-intercept, these numbers are roughly changing about like 2 to 3%. So I should not use the y-intercept 0 point either. The reason when the velocity is 0, the y-intercept 0 point, what we expecting is not the right one. There is always that error. I would suggest do not click that y-intercept 0. Instead click only last two. Okay, display equation and R square, and then leave it as it is because there is an error right here. That is not the real 0 point. Question. Okay, now let's you know how to do this thing. Okay, I'm going to do only for one graph. This one going to be what, displacement versus time, right? Displacement versus time, and then you need the axis title here. This should be time axis, and make sure you have all the units and everything. That should be displacement unit meters. Make sure all the terms are correctly done. Displacement, okay, yeah. And then I have a fitting equation, and then make sure equation is visible nicely here in the middle of the graph. All of them are there. Now only thing remaining to do by using this graph, I would like to do gravitational acceleration. Now let's take a look how to do that. Question. What we have here, This is y equal half, that's the formula, right? G times t to the power 2, right? That's what we plot here. So the y-axis on there is actually this. And the x-axis there on the graph is actually this. This is going to be x to the power 2 then, right? So which mean number in front of x to the power 2 represent half the g. That's the idea, right? So you take the number in front of the x square, that is minus half the g is equal negative 4.8618, which means the g from the graph, which is equal negative 2 times 4.8618. So that's our calculation. But you have to type those things appropriately, okay? So let's say that is from g graph 1, which is equal, you can do the calculation on the next cell, equal sign 2 times minus 4.8618. So 9.7236. My average is actually still better than actually the average, because average is 6.9. My graph value is 9.72. That's the other idea. That's we like to do this graphical analysis, because most of the time, if you have a graph, that will provide you a better result than the direct analysis. Okay, that's what we do in here. If you do individual point, you can see error is so huge. Sometime I got the error is 40%. But if I do many points, get the average, my error is so low. However, I do the graph, my error will be more low. So that's the idea here, okay? Let's do the percentage error. Equal ABS, parentheses, expected negative 9.81 minus calculated, close bracket, divide by ABS, parentheses, minus 9.81, close bracket, times 100. Now you can see my error is even less than 1. So we are in really good shape if we do the calculation with the graph. Okay, let me write it down here, the percentage error equation. Highlight this one. This is actually for analysis for the graph one, which I did now, okay, this part. Question. This is all the calculation for the graph one, and then make sure by now you should know when you copy paste this thing, if you have a graph, if you do a calculation for that, make sure you copy paste just underneath the graph. Okay, now since we're doing everything on the Excel, your report should be very easy to do. You just need to copy paste everything you're doing on the Excel into your data section carefully, one after the other, and then write it down the discussion part. When you write it down the discussion, you need to write it down the small paragraph for each table, each graph, and then so on, okay? These function, which are the one I mentioned last week too, these function you can collect. Don't include into here, okay? That is not correct. Your table, when you copy paste, none of these functions should show up on the table. That's very bad. Don't do it, okay? All these functions, if you want to collect, you should collect it on separately appendix C and then use it on the discussion. Let me delete that from here, because that might be a reason for some of you to actually use them. Get rid of that and then leave it here, okay? This is for V calculation, Vn function which I use, and this is for G calculation function which I use. Make sure you follow them very carefully. Don't do anything blindly, okay? Because if you do that, then that might be a reason for point reduction, which may not be a good idea, okay? That is for G. Let me delete this one, otherwise some of you might use it And this is for percentage error calculation. I use for geo. And then paste here. And then collect these things and then put all of them into appendix C and then name it appropriately. Name it appropriately, and then you have all the information you need. Let me highlight that too. That is actually all the function which I'm using, okay, on the table number 1. Do not leave any function on the table. That actually very bad, and then reason for any point reduction. Okay, question. This also, this function should not be there, okay. Should be separately collected into a different point. Okay, question. We erase that function too because some of you might use it otherwise. Okay, any question? All right, then let's do one more one more graph. We can do it for here. That graph is velocity versus time, right? So you remember earlier on the lab manual which I explained, we can use that information also to do the same calculation. Okay, let's see. If I do velocity versus time, I'm gonna delete all of these. Let's do velocity versus time here. Another graph, insert another graph without anything, just the graph sheet. Question so far? Okay, then let's add the data. Right click, double click on the graph sheet. Right hand side very top, select data. Left hand side you see add. And the next values again should be the time, right? We interested velocity versus time, which means starting from 0, column C, okay, table 1, column C, all the data, then everything, delete everything on the Y, and now Y should be velocity starting from 0, click and drag everything all the way to the last cell right here, D number 29. Click OK again. Now let's take a look at that graph. Can see graph looks nice, linear, but however, one data point clearly off. That's what I was talking so far. That first point which we thinking, which is the 0 point, the dropping point, which is incorrect. We cannot pinpoint, okay? So that's the idea, which means I should delete that number manually here. We don't need that number, or otherwise when we're fitting the data, we will get a huge error. So what we can do, you can actually change the data set. Double click on the graph tool, select data, click the series 1 on the left, remove, and then add the data set. Again, when you're adding this time, select without that 0. Get rid of time 0, start from the second data point all the way to the C29. When you do the Y, that is velocity, get rid of the 0, start from the second data point, and then all the way to the D29. Okay, click OK again. Now you can see graph looks nice, then off point is not there. So those are the analysis. Those are the visually observing the after you do certain calculation, whether that calculation makes sense physically. So that's what the engineering means really. You can't just blindly do something. This is the data set I got, so I am doing this. Like that is like you following the some information without thinking, without processing yourself. That not engineering. That can be done by anybody, even the 5th grader or maybe 2nd grader can be done, right? Those are the one you have to gain doing this thing with, if you want to become a real good engineer in the future, okay? So you can't just really blindly do things. I got a data set, I want to do Y versus T, I want to do V versus T, just plot it, and then that's it, finish the lab report. That's not what it's supposed to be. You have to look at it, what I'm getting, whether it's physically meaningful, why that data point goes off, what is the reason for that. You have to process, you have to think, then only you can become a better engineer in the future. Okay, so I'm telling this because this lab portion particularly I designed not to just finish the lab, instead of to show you what you're supposed to do, what comes next. Okay, that came up the reason by looking at your some of your answers for the exam one, which is extremely poor. Extremely poor. I mean, some data you received because of I graded it, and then if very tough instructor graded it, some people can get 0 very easily. Okay, except 2 people, I don't think anybody done good on the exam number 1 at all. Even those 2 people who got above 90, they don't earn 90. They actually got because of the curving. You have to check 2 places where the grade is. Okay, since it is came up, let me show you a little bit of that. The extremely important thing. So there's 2 places your grade is appear. Usually your submission link. That's week number 5. Shows a grade. Okay, right here you go into the submission link. You will see a grade. And then you go into another place called the final grade calculator, then you will see exam number 1 10%, that is the point carried towards the final grade. Then you will see another grade, that is the curved grade. Okay, we curved by, like, including the homework, almost like 15 points. I think it did too much curved, and even you get like 80s mean, you really don't earn that. Your real point is actually 70. You fail in the class, so that's really serious thing. You have to think very carefully, and one of the reason is that this may be the real challenging engineering class maybe you ever taking, and the any calculus class doesn't count to that level, because if you want to really see how the engineering class is done, you have to take the physics classes. Unless that, you're not going to see anything. Okay, so what I'm telling you is that you have to think about what you've done wrong, and then you have to approach accordingly. So to better understand how much you have to do, you need to take a look my answers. Keep this on one side, and then take your answer and then put it side by side. Then take a look how close your answers to this level. If not, then you need a lot of work to do. It doesn't mean that you can't do it. I'm telling everybody can do it, but you have to put effort. You have to really start working immediately. Okay, you can see this is the level I'm expecting. So my expectation are very high in the course. So it is up to you to earn the grade, okay, achieving that. So it is not difficult, okay, you can definitely do it, but you have to show that, because some people write it down, I don't know what you're doing, this is not high school, and I'm not your babysitter either. Okay, I'm telling this maybe only 1 or 2 times, that's it. And if you don't write it down, all of this step in this question part D, technically I can give you 0. Nobody can argue, okay, in this world. All I have to tell is show my answer. Student not following these steps, I gave it to 0. That's how you're gonna grow. Like in your, especially I'm telling this because if you just came out from the high school, I don't know, some of you done extremely poorly, okay? You have to really seriously think. I would strongly suggest is to buy, and then we can talk about it if you want to, okay? And then when we go into some of these questions, Not even close, because some people don't have equation, they just put some numbers and then put answer there. That's not what real engineering means. That like crappy, you know, very low level work. So you have to learn. So if you not learn that, this will continue. So that may not be a good idea. Okay, you can see how I write these answers. Okay, please take a look and then put your answer close by that, and then think about whether I wrote up to the standard expecting in this class. Okay, and then even this question, calculus people who are in the calculus 2 level, they done the correction, but the answers are very crappy. Either your calculus class not following that many steps, or I don't know what you're doing, or maybe you try to save the time. I don't know. I have no idea. Okay, I'm telling this because extremely important. Okay, because you have to really learn how to bring your level into the level of the class. We not bringing the class level downward. That's not going to happen. Okay, because the class standard remaining as it is, because it over the years uh, give a lot of good push to the lot of students. We have seen their success in their 4-year colleges, and because of that, we're going to leave the class standard as it is, and then you have to bring your standard up to the class. Okay, that you can do. Every single one of you can do. But if you are spending only that 3 hours and then 4 hours per week and then try to do this class, then you need to stop and then think twice. Okay, any question about it? Okay, so that's please think about, okay, because I see like about almost 7 students getting less than 50 points. That extremely poor. That's I wasn't expected that at all. I don't know how or what should I do. And then if you really want to talk, I'm very open. Just stop by after the class or maybe office hours. We can talk about it. You need to figure out what went wrong. Most important thing is that you have to follow class work. That one important thing, okay? To follow the class work, let me show you that too. So every class you have this information, right? So let's go week number 4. We do in class work. And then followed by that, I upload the answers for that. You can see chapter 4 answers, not the handwritten lecture note, which I do in. This is the separate one, okay? You have to take a look. If you take a look that, then only you know what I am expecting in the exam. Keep remember this. You can go into tutoring. You can go into outside tutoring. You can look at it many videos in the YouTube, in anybody in this world. But when it come to exam, you doing my exam. You are not doing their exam. It's like a dancing or music, right? You go into a person, you have to follow exactly that person is asking you to do. Otherwise, you may know how to dance, but you will fail with that person, okay? I think you get that point. Make sense? So please use any resources to learn. That's totally fine. But you have to follow exactly how we do the class. If you do that, then this is not difficult to do. Okay, we see people getting even hundreds without any problem. That because they really follow the class very carefully. Okay, question. All right, so please ask, please stop by and then ask, and also you can talk to our SI. He can give a lot of input how to success this class, because he know how this class is working and then functioning, how the method and then technique I'm using. So that will be very helpful. Okay, not any tutor. If you want to ask that kind of information, you have to ask from the SI who worked with me, because he took the 2 classes with me. He know how this class is running. Okay, the any tutor can give any information, but that depending on which class he took, which instructor he took, because every instructor is different, okay? Make sure when you come into a certain class, you have to follow that class structure very carefully. And if not, it's very difficult, okay, in moving forward. Please ask those questions. I would really appreciate if you bring that points, okay? Anything you think. Okay, so let's continue this part, this graph very quickly, and then we'll take a break, okay? This is graph. I need the graph number 2, part elements, axis title, horizontal, axis title, vertical, and then trend line, linear. Okay, this is now graph. Name this. This is velocity versus time. And this should be now x-axis, which is time axis, unit second. And this is y-axis, which is velocity, which is meter per second. Okay. And now I have an equation to show up here because I have the trend line you can see, but equation is not visible. Bring the cursor on top of the trend line, double click, then you see right hand menu bar appear. Keep the linear, that's what we wanted. Go all the way to the very end, click the last two, only last two, okay? And then take a look, number in front of the X, that should be the gravity now. Now you can see that number is actually much off than 9.7, which I got from the previous graph. Now, those are the things you actually learning here, not just only physics. This lab portion is specifically I designed not to teach you only physics, okay? To teach you what you're doing with the data, how you manipulate the data, what you're supposed to do next level, how you going to achieve what comes next, okay, in your third year level and then fourth year level in the 4-year college. Just passing the class, we don't need to do this much of work, okay? I can go very easily, but in that way you will get trouble in future. Instead, we go in here very rough path. In that way, your next level will be a little bit easier. Then you will be prepared for that, okay? That's the idea. Okay, so let's do the same calculation for this. I'm going to just copy paste that here. Let me do a different color there. This is for the velocity time graph, and then gravity from the velocity time graph is just a number in front of x. That must be the gravity. That should be 9.574 negative. Now you can see the error, change it to like about 2.4. That's still okay, I think. Now which we talking about earlier is actually the initial velocity, right? You remember when it drops, initial velocity is not 0. That you can easily see here. This number right here is actually the predicted initial velocity. You can see that. That's the y-intercept, right? The negative 0.943. So that is the predicted velocity from the graph. Okay, let me add that information also here. V0 predicted from the graph, which is actually that number minus 0.9743 meter per second. So that's why we're doing this different analysis, because the one of the analysis can't tell you all this information. So that's what you're going to do in your future. You can't just rely on some equation, plugging the numbers and then get the answer. That your high school level. And maybe your first year level, some of the basic classes, that's fine. But when it comes to the real engineering classes in your third year and fourth year in the 4-year college, nobody gonna babysit you. They're gonna assume you know this and that. They will proceed. If you're ready, you will successful in class. If you're not ready, then you know what's gonna happen. So what I try to show you is that how much work ethics you need, how much commitment you need come into this kind of class. If you don't have them, then you have to change your work habits and then practice yourself. Okay. Question. Okay, let's take a quick break then, like maybe 5 minutes, 10 minutes max, okay? And then this is all actually, this lab, basically, if we done for one object, technically we're going to repeat the same thing for the golf ball. And then at the very end, let's see what's going to happen if I send the coffee filter downward direction. That will not behave similarly, this one. It will behave very differently, okay? That's the plan. So let's take a break, guys. So you can successfully complete this class with the grade you're hoping for, but I'm telling you that something is wrong. Basically, the time commitment you're putting is not good enough. That's what I can understand. By looking at the grade, you might be spending 1 day, 2 days just before the exam to prepare the exam. That is not definitely okay for this class, okay? This class need at least 15 hours other than the class time. So including homework, everything, okay? If you at least 10 hours beyond the class time per week, okay? Then you can definitely successful. Please ask any question, okay? So let us take a quick break. Decimal places, not more than 4. Yeah, I just open the start the recording. It means only this copying these 2 lines. Okay, that's all. Okay, so which means the error for this one, let's assume this is measured in the meter ruler. So let's reformat this to represent only 4 decimal places. Otherwise, it's not really anything meaningful. Highlight, format cells, numbers, 4 decimal places, not more than 4. Because now we're thinking like, if we measure this really, how much accuracy I can go, right? So that's the idea. Now in the time, let's say if we measuring this time also, we can't go really many decimal places. We have a stopwatch in our lab, and also there's a setting actually which we can do this measurement. That setting actually can provide you 1/60th of a second. So that is the smallest value it can go. If I do 1/60th of a second, assuming if we done this in class setting, so that's about like another 4 decimal places, not more than that. Okay. So let's assume if this is a measured parameters, in the class setting, let's reformat this also for 4 decimal places, which mean, of course, my velocity also should have to have only 4. You can reformat all of these actually to 4 decimal places. All of these. Highlight, right click, numbers, 4 decimal places, good. And 4 decimal places means actually about like 4 significant figures in my velocity. I should have maybe 3 decimal places plus the number, right? Let's change that a little bit. It doesn't matter if you leave it there because our idea is not calculating velocity here now, calculating the error for that, okay? Now let's see how to calculate the error. Because I need that information, because I want to identify what is the delta y and then what is delta t to do this calculation, right? So delta y is now delta y is actually error of the meter ruler. Error of the meter ruler is 0.0005 meters. That is about like 0.5 millimeters, right? And then delta t again, that I can't do this estimation, only you have to go 4th decimal place and then select that decimal place value. So which means that should be 0.001 second, okay? So that's the error of each instrument. By assuming if we do this in class, okay? Now by knowing that, I can do this calculation, right? That's the calculation I want here. Let me make it small and then leave it here. Okay, so that is our equation. So we can do now our calculation. Okay, let's do that. So how to do it? Equal sign. Vi is this calculated value times SQRT, parentheses, another parentheses, delta y, which is 0.305, divided by yi is actually this cell value, okay? B38 close brackets power 2 plus open brackets delta t 0.301 divide by cell value C38 close brackets power 2 close brackets again for square root, hit enter. You will get 0 there. Reason, there are some of the zeros on this line, so that's why it's okay, just leave it there and then click right hand side very bottom corner, then drag. Rest of the calculation should do automatically. Only the first line I'm not going to get an answer because we know all of this first line I can't do that calculation at all. Okay, I'm going to highlight that, showing that we can't do that calculation. Put the 0 here purposely. Okay, I can't do that calculation. Technically this line we should not do any calculation at all. Okay, question. After you do that, yeah, go ahead.
Professor, could you just click on the equation again?
Oh yeah, so let us copy paste. Let me
Thank you.
get rid of the first line and then I'm going to copy this second line. Okay, this one. And let's copy that to somewhere here because I don't want anybody to leave that on the table. Okay, so this is the delta V equation. Okay, delta V equation. Right. So I think still you can see that. So let's do the delta G. Delta G equation you can see here. So let's write it down, that one. Equal sign. G calculated. Now that's the problem because G calculated is actually here. Okay, but you can click that cell. It will do the calculation automatically for you. Okay. So G calculation is actually this cell right here. Click on that. Should start after first two line. Let me do one quick thing here. Maybe I need to get rid of both this line because on top line, previous table, we're not doing the calculation for both of them, right? G, we're not doing calculation for both first line, we're starting from the third one. When you do the G calculation, make sure you start at that third one, okay, this one. For velocity, that's okay, just leave it this one open, but for the G, start from the third one, okay, not from the second one. Equal sign, G calculated is this number right here. Click on that, E12, and then times SQRT, open brackets, another brackets. Now you can see this is the equation I am following. Delta V O VI. Delta V is the calculated value right here. Divide by V for that is the number just before that, okay? Delta V O V, close brackets, power 2. Plus open brackets delta t over t. Delta t 0.301 divide by time is actually the cell right here. That's the third cell on the column C, okay, C40. Close brackets power 2, close brackets again, hit enter. Let me copy paste that function also. Somewhere here, that's the two function you need to do that calculation. Delta G. Okay. All right. Question. We make this a little bit of smaller, then you can see, I think, everything. Okay. Now, if you do one calculation, click and drag downward direction, then it do the calculation for you automatically. Okay, you can see the error calculated for gravity is very, very small. This error is actually propagation of error because of measurement. Okay. So one other thing we have to do, there's many decimal places. There's no meaning. So I can go maybe 3 decimal places on my velocity, which means this has to be reformat into 3 decimal places. Both of them has to be reformat to represent 4 significant figures. Okay, reformat, format cells. Maybe let's go scientific and 4 significant figures, no meaning anything more than that. Okay. You can see now it's a very small number. Okay, so that's why I'm keeping it scientifically. Format cells, scientific. Also, you can go for significant figures for gravity, also calculated in totally. Okay, question. Everybody okay with that table? This equation should go here. Okay, since it is much larger, I just leave it outside. But technically, I think you can add into here if you make these cells little bit wider. Yep. So that will fit nicely there, and then make sure you put all the units and everything as you before you copy these tables into the into Word file. Okay. So we completed that, and then we can take a look the other object very quickly. This table you're doing only for the base, only for the golf ball. Okay. This error analysis you can see we can do for the other object too, but it's not really much useful. Since the accuracy of the measurement are very high, error is actually extremely low compared to the numbers. This is 5, error is like 0.002. It's extremely low. There's no meaning really doing this calculation. And the gravity also you can see error is extremely low. Question. Okay, then only we're going to do for tennis ball, we're going to do only the similar to table number 1. We're going to just calculate the gravity by using that one, just simple calculation. We'll use like maybe 10 data points is good enough. We don't need a lot. And the last one, we can't do this analysis at all for the coffee filters because it not behave this way. It's completely different way. I will show you in a bit. Okay, question so far. Any question on table number 2? I forgot to write it down here. G calculation is also the same kind of equation. That's why it becomes the equation is the division rule, right? G is delta V over delta T. Then you have to look at the division rule again. That's why the formula for these two you can see very different, very same, but the variables inside are very different because this one you have velocity on the top, this one you have displacement on the top. Okay, that's why if you look at it carefully, propagation of error analysis for the velocity you have the delta y over y here, but the gravity you have delta v over v. Okay, so please make sure you follow those things when you really doing the analysis. That's what you have to take a look, what equation we using, how the equation used, why that equation becomes like that, what theory, what rule plays the role behind that selection, and then so on. Then you get familiar to these things. Okay, all right. Anybody have any question from table 1 or 2 or any graphs right here? Then let's do same for the tennis ball. It's not really even important, but let's see whether there's anything changes for the tennis ball. Okay, that's what we like to see by doing the different object. You can go back to the tracker and then I can insert a new tab. You can go to file and then click on new tab. Then you can insert a new tab. And then you have to upload the new video import, and I need the tennis ball, double click. Going to be the same process. There's no anything new there. Okay, exactly the same process. Click OK, right click, filters new, rotate 90. Then you have a new video on the right way. And then we have to take care of the frame rate, right click flip setting. That's the most important thing. Frame rate should be 240. If not, our time axis will be very incorrect. And then again, the same thing. I have to have axis right here on the top, coordinate axis, this menu icon, just top of the video, and then click and drag. X-axis should be exactly on top of the ball. Y-axis should be a little bit away because I want to observe how the ball will fail. Ball will fall down, okay? I need to observe how it falling down as it goes down. And then I need to tell how height, right? Then to the left of that axis coordinate, there's another icon. Click there, new, calibration stick. Then click the shift. Whenever you hit the shift, keep clicking that, then you will see the mouse sign, cursor sign changes into kind of box sign, then bring that on top of the origin, click there. Then it becomes blue. Then bring the mouse cursor all the way to the ground level, click the shift again. By keep clicking, click the mouse again at the very bottom, the ground level. Then you will see this brown line appear. At the middle of the blue line, there's a number. You have to change that, okay? Remember the number we used earlier, 1.829 in meters, right? That's the right height, 6 feet above the ground. Now we are ready to take the data because we tell the program this is the height. You can use as a reference. This is the time of the frame rate. Then the program know how to give us the right information. That's all then. Then all you have to do, find the ball moving location, right? Maybe ball is not moving exactly from there. I need to exactly pinpoint that just before it leave from the hand. Maybe right there. Here, my line is on the right location. Good. Then to collect the data, you can see an icon called create just above the video. Click on that, point mass. Then the graph will appear here. Y-axis should be changing to, click on here, change into Y position. X-axis remaining same, it's the time, right? And that's all really. This slider changes whenever you click the point mass. You have to find again the right location. And okay, let's start from there. And then technically I can actually change this. You can see if I set this time to 0, it's going to start from 0 automatically. That is better. And that's all really. Then you click the shift, hit the shift, then the mouse sign changes into box. Bring it to top of the ball. Now we are tracking the center of mass of the ball. You have to be careful. Ball is much larger now. Bring exactly on top of that. You can see when you change in the cursor, this Y position changes, right? If you bring it close to the ball location and then observe the Y position down here, down on the slider line, that the yellow box, I can pinpoint the 0 actually if I want to. I'm interested Y0, you see that? So just bring that, change the location of the mouse until that Y shows 0, 0. Then I can start from there. Then click there. Now you can see that slightly changes. Let's change that again. Click on the point and use the arrows, then you can pinpoint the Y equals 0. Now you can see my data set is good. Starting time is 0, Y is 0. I don't need to do that adjustment which I did earlier. Okay, those are the things you have to really play around and learn, right? Those are the skills you need to gain. Nobody's going to teach you those things, okay? So it's not just like going to a class and then sit down and expecting everything to happen automatically and then you absorb everything. That's not possible in real engineering level classes. Okay, those are like, very basic level social sciences, language arts, those classes. you can do that. But when it comes to real advanced engineering in your third year, fourth year, you have to do a lot of time and effort. Okay, so then that's all. Again, the same thing. Let the ball moves, maybe a couple of clicks, maybe 5, 6 click, shift, and then click on the ball. Second data point, another 3, 4 clicks, shift, and click on the ball. And make sure you're clicking exactly center of the ball. We're tracking the center of mass, okay? Maybe 3, 4 click, shift, and on the ball, maybe 3, 4 clicks, click on the ball, exactly. Try to click exactly the center, but it's difficult to track exactly the center, okay? But as close as possible. Another 3, 4 click. As the ball goes down, you know ball is moving faster and faster. Because of that, maybe number of clicks I have to reduce to maybe like, I don't know, maybe 3 also, not more than 3 probably after halfway, because it actually going much faster now. Okay, after that point, probably it's moving too fast. Now you can see the shape is nice, right? So still I'm getting really nice data shape because we're expecting parabola. However, if you look at the ball path, it actually vertically you can see moving a little bit slanted, right? It's spinning because you know tennis ball can spin, it is larger, right? You see that? Now I started here, that's the hand, so it should be on this area, but now it's right here, it is spinning, right? So those are the errors really. So it really spinning little bit, goes away from the vertical line. There's an error. Those are the error we see. That's why we're not going to get 9.81 after we do the calculation. You will get close by within like 2% error, but not exact 9.8. And then stop maybe just before it hit the ground. Okay. Do not collect the data after it hit the ground. Question.
How did you change the
Yeah.
graph to the y-axis
Oh,
again?
that's just click on here on the on this. There's a term, right? It says X first. Just click on there, then you can select the Y.
Got it. Thank you.
Just one click, okay. Okay, then let's copy the data. Right click on the graph, analysis. I can actually do all the analysis here. Let's do the analysis here to get practice, okay. So now if I know this should be a parabola, right? You can see nice fitting. You can see the number I'm getting 4.97. So my G, twice of that actually much accurate even than the previous. Right? So those are the things we can do very quickly. Let's bring this data and then do the analysis also. We don't need this many data, right? Just 17 data points. Copy anyway all of them. Copy and then go to Excel sheet. And now I don't need to recorrect anything, right? But anyway, first we'll paste into here. There's nothing to recorrect. Then we'll copy again, okay? Y-axis goes into here. Right click, see which one is better. So I think if you do this one is better, okay? Maybe the first one or the second one is better. And you can see there's a couple of data point goes off. You can make this area, all the lines are visible right here. Then you can actually extend your table, okay? So I need like maybe 3, 4, 6 or so rows. Extending those rows are much easier now. I extend the data table up to here, okay? And similarly, let's copy time also separately from my sheet number 2. Right click. Yeah, I think either one works, values or the first one. But if you go values or the link, then the data looks nice, the formatting, okay? It's good. Now, rest of the calculation is exactly the same thing we done. So let's do that again. It's the same thing. There's nothing new actually, but let's do it again because there's a couple of questions we should answer. Okay, question. All right, so let's take a look. Velocity calculation, you know. First line, technically, there's no meaning doing it. I'm gonna get rid of that line. I'm gonna start from this line, okay? And equal sign, twice, 2 times y divided by t. And this function I will copy paste for your reference purposes later, right here, okay? On this area, let's see, this is for vcal. And again, this vi, don't misunderstand, and that is not I really, it is nth value, okay? I'm gonna put this n here. Otherwise, I know later there may be, you might have a difficulty why it is. It may be the initial, it's not initial, okay? It's nth value, okay? And that's the function I'm using for v. I will use a different color there, okay? And then you click and drag this cell, click on the right hand side very bottom, drag all the way to the down. It will do the calculation for you again. Like we done earlier, we should reformat all of these data to represent only maybe maximum 3 decimal or 4 decimal places for first 2 lines, then the last line. You can leave it like that, it's okay. But maybe 3 to 4 significant figures, not more than that. Assuming if we measure this in class, how many sig figs I can have. Because in the simulator, you can have many. Simulator doesn't matter, it can give you many. It's a calculated value, okay? Let's do gravity equal sign. Parentheses V2 minus V1 delta V over open brackets T2 minus T1 close brackets. You can see that number is very bad, but let's take a look what I get next, okay? Because we know the number will be different because we're doing each two data point, right? gcal I done this way. Click and drag right hand side, then you will see very different numbers. See that? Let's check the average. If all good, average should be a better idea. Average should be a better one. Yeah, average is 9.87, so we are better than even previous case. I think within like 2% error also. So that's the idea. And this one actually only one data point goes really off. That is the first one. Other than first one, there's another like 6. Most of the other data points are actually better. Question. Okay, then we'll do percentage error equal ABS parentheses expected minus 9.81 minus the calculated. Close brackets divide ABS open minus 9.81 close bracket times 100. It exactly same thing I'm doing here like the table one. There's nothing new, okay? And do it all the way to the last one, average cell 2. Because in the average you can see it's better, right? See that? So the average, I'm getting really low percentage error. This is the average. This G AVG. G average, okay, right here I'm doing. So that you may need to answer all the question asking on your lab. Question. Okay, then let's take a look. I think the both graph I have to remake, which I done for previous, right? Let's remake those graph. There's easy way to remake. Since you have a graph already done, you can actually duplicate that graph and then bring into the next. That's one way of doing it. So you can try to copy paste this and then paste somewhere. That's the same graph, okay? Then bring that all the way to the next graph instead of, you know, rewriting all of the information. That's the easy way. So you bring it downward to next table, table number 3, okay? Then after you bring that, all you have to do is actually change the data. So now I have the graph already, but I have to change the data, right? Double click, select data, delete the series 1 because that is from the previous table. That's not what I wanted. I need the new data set, right? So the add again, X values, time axis. For displacement, you can go from 0, nothing wrong. But if you skip the 0, that also fine. Nothing wrong gonna happen, okay? And Y values is the displacement right here. Click OK. Click OK again. You can see that all the graph formatting now stay there. I don't need to worry about at all. However, what disappears is actually the trend line, right? So I have to redo the trend line. So that way you can save the time. Those are the things I'm telling you. You have to really get into this and then check how to do easily and then so on. That way you can always improve your skills than what we're doing in the class. Okay, that's what the expectation are. So double click, left hand side very top, chart elements, trend line. Just put the linear, but I can change it later. Then the line will appear. Double click on that line, dotted line, double click. Last icon from the very top, select polynomial. And then go all the way to the bottom. You can select all these three. Click only first two, then I will show you one other information we can extract from there too. Now you can see equation appear, right? See that? That equation, if you take a look, the first part right here, 5.08 multiplied by 2, that's about 10 from the graph, right? So that number gonna actually change if you go here, and then those are things you have to take a look yourself. If you say that graph to go over 0, 0, purposely you can see that number changes. The reason this graph must go 0, 0 point. So we have to let it do that, okay? If not, our error gonna be a little bit higher. So that's the idea, okay? Make sure that click. And now 4.9 times 2, I have a really good idea, really good number, 9.8, okay? Make it a little bit smaller, and then that is graph number 1. Now to do all the calculation for graph number 1, I'm gonna bring this calculated values and then adjust there, okay? So I'm going to copy paste that into here. Then my calculation will be easier. This number going to be now twice number in front of the x square, which means negative 4.914. See that? My gravity from this graph now very better. Now you have to think about what happened, why the tennis ball give you better answer than the golf ball. So what kind of things happen? Those are the discussion. You have to do it yourself, okay? Then you will learn more. We technically don't expect anything to happen differently between these two objects, but there are considerable observational differences between these two. So all the numbers are better, average is better, so the value getting from the graph is better too. Question. That is the equation for percentage error calculation, okay? Let's do the other graph too. And then I think we have enough time to go over very quickly last part too. So let's quickly do the other graph that also you can copy paste and then bring, you have to copy paste the graph, okay? Whole graph, copy and then go different location, then paste it. Otherwise it's going to paste on top of that graph, okay? right here, my new graph. Now I need to add the new data set, right? You can either leave this as it is and then add the new data point too. So let me show you how to do that too. Double click on the graph, select data, leave the series 1. That is actually the golf ball, right? So let's add the new data point, another new series. You can name it even tennis ball. X should be now the time, that is all the numbers after 0 in column C, table number 3, okay? Don't include the 0, you know there is a issue with previously. Velocity after 0, all the numbers in the column D. Click OK, click OK. Now you can see that data set is actually going top of the previous data set. I can't see it because it exactly behaves the same way. I can change the color on these data points to see whether it is visible. That's one way to do that. But otherwise, it goes exactly top of that. Double click, select data, series 1, get rid of, and then let's add the new data set again, and X values, time after 0, Y values. Those are just trial and error. You can get more practice, okay? I can do all the graph in one sheet. I can do graphs separately in each sheet. There's a lot of things you can do, okay? Nice linear graph, double click, left hand side very top, trend line, linear, trend line, linear. Bring the cursor on top of the trend line, dotted line, double click, right hand side, third icon on the menu bar. Keep the linear, that's good, it must be linear. Last two icon must be clicked. Now you can see velocity graph giving you a lower value than the displacement graph. The reason velocity starting point is actually not the zero velocity always. We have that error. And also if you doing the velocity points are far away each other, then we have the error there too. You have to think about, right, those things in the discussion. Why those small changes appear on this is the same data set. Why this behave differently than the other, and why the numbers are slightly different too, and then so on. So question. So which I done earlier is actually mistakenly I add the numbers into here, but in your side you should be fine. So this is our new graph. That's okay. I will leave it like that. So make sure when you copy paste the graph, make sure you do the addition for the new graph. Okay, data addition. Question. Let's do this calculation also then very quickly. Then we can finish all the important information. G is the number in front. Now you know that is just negative 9.574. And you can see within the 2% error, not bad still. Considering this is a real experiment, we drop the ball, we record the video, we got the data, we analyze everything. So considering everything really what we done, it's a really good number. So very rarely we getting this kind of number. This is extremely good. We expecting 9.81, we getting 9.82 here. That's a very good number. And the percentage error calculation, I will copy paste that also to here. Okay, question. All right, now you have all the calculation done. Table 1 completed, 2 graphs, all this calculation, just copy paste just below the graph, okay, on your table. All the function, collect it separately on appendix C. And table 2 we done very in detail. All the function you should copy paste on appendix C or to discussion, either okay. And if I doing the same calculation again and again, you don't need to repeat that function again and again on the discussion. You have to discuss only once. Have you done that calculation with this function? All gravity done with this function. That's all in table. So it's a fairly very easy way to do by calling the function, but it's you have to be clear there. Okay, what you're doing, you call in the the certain function for Excel, how you call it, just you can copy paste, or you can put the function into appendix and then say refer appendix C. We use this equation number 4 in appendix C, and then so on. We have to just take a look only coffee filters. I think we have enough time. 10 minutes is good enough, that because we're not going to do any analysis with that. File, new tab on the tracker, bring the video, import coffee filters, bring that video. That's going to take a while to upload because it is actually more slower than the other two because it's too light, right? And not only that, what the copy filter is actually doing, it actually experiences what we call the upward friction force, right? So it is actually called the drag force. We will talk about next chapter actually when we start the Newton laws. But until that, right click, filters, new, rotate, 90 degree, and then right click, click setting, and do this 240, okay, frame rate. Now we're ready to get the data. Now the idea here, this will not behave as the previous because this will experience what we call the drag force. What is the drag force does? We will talk about that sometime this week or next week. Now when the copy filters goes down, when the copy filter is moving down, so the air is actually goes upward direction, right? Both side, that will create the drag force upward direction if D, let's say if D here. And this copy filter has a small weight, right? Because of that, there's a weight downward direction. At some point, what's going to happen, velocity is slowly increasing because the gravity downward. There's a certain point where copy filter reach what we call the acceleration 0 point. So at that point, coffee filter does not feel any gravitational drag at all. It's going to starting to moving at constant velocity. That called the terminal velocity. That's what we try to find. So the coffee filter is moving after some point terminal velocity. It might reach that, it might not, depending on how high you drop. So that's what we try to see on the next part. We're not going to do any graphing, any tables or anything. We're going to do all of those directly with our simulator, okay? Directly with our tracker software. Question. Don't worry about too much the drag force and the force of gravity, everything which I said there. We will talk about those things in next class or the following class when we discuss the Newtonian laws. Okay, but what really happening is that at certain point, the gravitational acceleration is not really doing anything to the coffee filter. It will reach what we call the terminal state. So after that, it's going to go with the constant velocity. That's what we try to see, whether that is really happening or not. If it happens, we can see that in our graph, okay? So the same thing, click this one, axis, and then you have to figure out when the coffee filter moving from the hand. You can see hand is go a little bit up and then left, right? You see that? So I have to figure out exact location. Maybe that is good, I think. If there's error there, nothing to worry. We're not going to do any gravity calculation. Axis, and then I have to have the new calibration stick. Shift and then click on the origin. Shift and then click on the ground here. And then this number should be 1.829. And then I need to just create point mass and then click on the X on the graph into Y. Now I have to collect the data. You can see this slider changes back into 0. Setting, change it to back where the filter is starting to move away from the hand. You may need to increase the number of click. Each click, how many number of so each click, how many number of frames are changing. You can change that number into maybe 2 or 3 because this is too slow actually. Okay. I need exact location where it goes away from the hand, maybe right there. Yep, that's good, I think. Now let's see this frame, set it into 0. Shift and then click very bottom. I'm gonna track this very bottom corner, okay? And then I want to make that is 0. You know what to do. So you can click that and then change that also into 0 a little bit. See that? If you click on the red core and then use the arrows on your keyboard, up and down, you can find the Y0 exact point, okay? And now I'm starting at Y0 and the frame 0, T0. So all I have to do, click couple of points. Now you can see it too slow, okay? Shift, click on the filter, then maybe like 5 click. Filter, I'm tracking the very bottom piece. Don't click too much because we don't know when the terminal velocity approach. So I may need probably a little bit of more data in the beginning. So the terminal velocity approach may be halfway or maybe at the very end. I have no idea. So you go like maybe 3 clicks and then collect the data. You can see now it moving a little bit sideways too, right? So that because of the air friction is now too high, you can visually see that clearly than the two previous objects. So those are the things you have to observe and then discuss in your discussion. And then click maybe like 2 or 3 clicks, not more than that. More data you get, actually the better for this one particularly. Because we have to see when the terminal velocity approach. It may not approaching at all, I don't know. So we have to take a look very carefully, okay? And also you can do this your own, right? You can record this video your own and then you can test those with the tracker. And do not collect any data after it hit the ground, okay? I'm going to collect the data very close to the ground because I don't know when it is actually, yeah, that's the last one. When it is, I don't know when it actually approached the terminal velocity. One thing you can clearly see here, shape is look like parabola, but not really. You can see when it goes to this range, it becomes more linear. You can visually see that this graph is very different than the previous two. Right click on the graph, analyze. Now that's our graph. You see, now initially you have a little bit of parabolic shape, but after some time you can see it becomes more linear. Now parabolic fitting, you can see not really good fit at all. You see that? So pink color line is a parabolic fitting. That is not good fit at all. Let me change that into a different color, then you can see that. So that dark blue line is actually the parabolic fitting. So that not fitting at all. That's indication that this is achieving the terminal velocity. Because of that, the gravity is no longer acting after a certain point. Now, usually, terminal velocity appear after like halfway or more than halfway close to the ground. Because of that, what we're going to do, we're going to select this, click and drag this last couple of data points. Okay, only last couple of data points, click and drag. Then change the parabolic fitting into a line. Right here, okay, fit name, change into a line, okay, parabolic fitting into a line. You can see last data points are really good fit with the linear. If it is real parabola, I should not be able to fit that way, a long range parabola into a linear, right? So which means after about like 2/3 of the motion, it approach terminal velocity. That velocity is the number in front of this t, a. Constant A is the terminal velocity, that is 2.405 meter per second. So that's what I'm asking on the last. You can actually copy this graph directly from here. You can save it if you want to, or print it directly from here as a PDF file, and then you can add that into your lab report. You don't need to really redo this one. Okay, make sure you select only this range. Okay, if you change the selection, then this number changes. So make sure you add that, only the graph. We don't need even data, okay, or anything into your lab report. You don't need to replot this with the Excel. But if you want to, that also possible. You copy this data, bring into the Excel, remake the graph. Now you know what to do. You have to fit only last data points with the linear fitting, okay? That's what you need. Let me go back to your lab manual to show you that what you need to answer this last part right here, okay? So what is the, explain the behavior of the velocity of the object. We can see velocity becomes constant after some time close to the ground. Then you can find the terminal velocity by fitting the last data points, and discuss the object motion and explain why the object velocity becomes constant. Reason it approach what we call the terminal condition. At that point, the acceleration becomes zero, acting on the object, okay? So that's what you need for your report and everything. So I think we covered everything. So what else we need? Let's see, table number 3 fine, 2 fine, 1 fine. There's 4 graphs on here. All should be going to your report, and also the 5th graph is actually from the terminal velocity. Okay. I think we've done everything what you need for the lab. I will add another small video, not the class video. Class video is too large. I will add another small video here, which actually show you only the calculation part, how to make the collection of data, how to copy the data from the tracker to the Excel, how to make this graph only for one object, okay? At least for the tennis ball or the golf ball, at least for one object. A small video like maybe 10 minutes. If you have a difficulty with doing this, you can refer to that, okay? And also, I will add couple of small videos going forward. Every weekly folder, like week 6 folder, what we start in talking about chapter number 5, Newtonian mechanics, right? Newton laws. I will add a small video, like maybe 3 minutes, 5 minutes, maximum 10 minutes video explaining what's the Newton laws, what we're trying to do Wednesday. If you can watch that video before the Wednesday class, watch it Wednesday morning or maybe Tuesday night to see what we're trying to do, then that way you actually can come prepared. Okay, that's something will be helpful to you to improve in the class. Okay, I just worrying by looking at the exam number 1 grade. Okay, all right, so I think we should stop here. If you have any question, stay in the call. Otherwise, I will see you guys on Wednesday. Okay.
Thank you, Professor.
Yep.
Thanks, Professor.